Algebras. Welcome to your Chapter 13, Lesson 4, Day 1 notes. So today we're going to start talking about those recursive sequences that we had mentioned are the final type of sequence we need to analyze. So what is the difference between arithmetic and geometric sequences? So that's what we had just spent Lesson 3 kind of combing into, is arithmetic versus geometric. Now, what we'll do here is we'll kind of start looking for the common difference for arithmetic or the R value, the common ratio for geometric. So arithmetic are like a linear pattern where we are changing by adding or subtracting the same amount from term to term to term. Geometric are we are changing by multiplying or dividing from term to term to term by that same amount. So the D value is the common difference and the R value is the common ratio. So I can immediately tell on part A in exercise 1 that I have a common difference. What is my common difference? Adding 2, adding 2, adding 2. So this is an arithmetic sequence, and my D value is positive 2 because I'm adding 2 to get from term to term to term. Looking at B, let's think about it. I would add 3 to get from 3 to 6, but would I add 3 to get from 6 to 12? No. So this means this is geometric. And my R value is 6 divided by 3 is 2. 12 divided by 6 is 2. 24 divided by 12 is 2. So my R value here is 2. This time I'm multiplying by that every time. So that's just since we had just gone over that in lesson 3, I'm actually going to keep going, but that's just a review of how we started talking about sequences, is defining them as arithmetic versus geometric. Recursive sequences are different in that they use the term directly before to figure out the next term. Okay, so you have to plug in each step along the way. So this is a little bit different. You have to show all of your work to get from the initial term you're starting with to all the subsequent terms. So you have to actually plug in, use that previous answer to plug back in and find the next answer. So recursive sequences are a little bit different, okay? We're going to start with exercise 2A, where I know I have an arithmetic recursive sequence because I'm given a plus 6. So I add 6 from my first term to get to my next terms. It gives me an f of 0, which means my initial value is 2. So this is my 0th term right here. Now what I do is, starting from there, to find the next term, what would be considered the first term in the sequence, I now take the previous term, which was 2, and I add 6. Now I get 8. So now to find the second term, term 2 in the sequence, I take the previous term and add 6. To get the third term in the sequence, so this is the next 3 terms, how I'm getting that, I take the previous term and I add 6. So 8, 14, and 20 are those next terms in the sequence. So notice the notation is a lot different than how we worked with our arithmetic sequences prior to this. Okay. Now in B, I can tell that this is going to be geometric because I'm multiplying by -2. So this time to figure out my sequence, I'm going to take it, I'm going to multiply it by -2. And I'm going to start with this first term, f of 1 is equal to 1. So I start with the given first term. And now to figure out any subsequent terms, it says I take the previous term and multiply it by -2. So what's -2 times 1? It's -2. Now I use this term to find the next term. I take -2 times that term, and I get +4. Now I take, to find the fourth term, -2 times this term to get the next term. And you can see how we're bouncing a little bit there, but that this is geometric for these three terms. Notice these three terms were term 2, term 3, term 4, because we were asked to find the next three terms. And here, the next three terms were term 1, term 2, term 3, because we were given the 0th term in this sequence. So these were our three terms, and this was arithmetic, because we were adding to get from one term to the next, to the next, to the next. And there's my three terms in my recursive sequence, and this was geometric. Now, the thing is, sometimes in recursives, you can get a little bit of both. So you have to be really careful about what is the specific notation you've been given, and you take that previous term, and that's what you plug in for the next term. Okay, so it says find each value for f of n, right? It gives you the start. So every single time you're going to be given the start, and this sequence is defined recursively by taking our previous value and subtracting 5. So we need to get from f of 1 that we've been given as 4 to f of 3. So that's what we need to do. And since it's defined recursively, we have to use our previous term in order to find the next term. So notice what we do is we find n by saying, okay, we know the previous term, let's find the next term. So if f of 1 was 4, f of 2 takes 1 and subtracts 5 from it. So that's the first term, subtract 5 from it, now you get -1. F of 3 is going to take the previous term and subtract 5 from it. And that's where we were asked to get to. Notice in the next one, I am not only multiplying, I'm also going to be adding. So look at this function definition, this recursive definition. Okay, I'm given f of 0 is -8. I have to get to f of 2. So I start with f of 0 is -8. Now, I take the previous term, I multiply it by -1, and then I add 2. So to get f of 1, I multiply -8 times -1, then I add 2. -8 times -1 is 8. 8 plus 2 is +10. In order to get the next term, what I do, the second term, is I take this, I multiply it by -1, and then I add 2. Well, -1 times 10 is -10. -10 plus 2 is -8. I know that I was only asked for f of 2, and I have the correct answer, but I want to kind of show you something. What if I did have to go to f of 3? I take the previous answer, multiply it by -1, and then add 2. +8 plus 2, I'm in a loop. In recursive sequences, the reason we need to take that previous term and then plug it in is you might be stuck in a loop. And this is a perfect example of one where we're just going back and forth. That actually happens a lot in recursive sequences, so don't be super surprised when you see it happen. All right. why don't you see how you do on C, which is tough, but I want you to see how you are. So pause it here. See if you can plug into C. And then I'm going to do the last one, which is one more new type of notation for a recursive sequence. Go right ahead, pause it here, try C. All right, let's check our answer. How did we do? Did we get that f of 5 was equal to 9? And here's the work. Plugging in, half of 16 is 8. 8 plus 4 is 12. Take 12. Half of 12 is 6. 6 plus 4 is 10. Take 10. Half of 10 is 5. 5 plus 4 is 9. So using the previous value to plug into our sequence recursively. So finding that straight down the line. All right. Last type of notation for recursive sequences that you may end up seeing. So you also might see this a to the subscript n is equal to n minus 1, the previous term, plus n. So what this means is, and this is a real true recursive, is this is also related to the nth term. So your n value is used in two spots. So it means that the value you're adding here is different from each example. So here that value was always 4. If I was dependent on this, here it would be 3, here it would be 4, here it would be 5. So the value is going to change along with the nth number term changing. Show you what I mean. If this is my start, a to the subscript 1 equals 11, and I'm finding the next 5 terms in my sequence, I'm going to take a to the subscript 2, and I'm going to take the previous term 11, and now I'm going to add 2 to it because I'm subscript 2, that's my n term. So now I get 13. Well, now for the third term, I take my previous term 13, but I'm adding to it 3 to get to the next term. So what I've added has now changed along with my term number. So what I'm actually adding each step along the way is different based on the term number. So a to the subscript 4 is 16 plus 4. And now a to the subscript 5 is 20 plus 5, or 25. I needed the next 5 terms, right? So I need to keep going. A to the subscript 6 is 25 plus 6, and there we are. There's my next 5 terms. Right in order. So you can see why recursive sequences require you to actually use that previous term and plug it back in. We'll keep practicing these. Practice tonight on homework number 1. But this, of course, has been your Chapter 13, Lesson 4, Day 1 notes. Let me know if you need anything, and I will see you very soon, Algebras. Bye.